Question 1, 2019, Part A. A particle P of mass 3 kilograms is projected along a rough inclined plane from the point A with a speed of 4.2 meters per second. The particle comes to instantaneous rest at the point B. The plane is inclined at an angle alpha to the horizontal, where the tan of alpha is 9/40. The coefficient of friction between the particle and the plane is 3/20. Show that the deceleration of P works out as 15g/41. Then we have to find the distance from A to B. And then after reaching B, the particle slides back down the plane. Then we want to find the speed of P as it passes through A on its way back down the plane. So the forces acting on the particle when it's in position B. So the downward force is the weight, which is 3g. The normal reaction R is perpendicular to the surface of contact. Now the particle is accelerating, or should I say decelerating, up the plane, which means that friction applies down the plane. So friction is mu times R, so that's going to be 3/20 of R. Now we need to resolve this weight into parallel and perpendicular components. The slope is inclined at an angle alpha, so that means when we resolve the weight, 3g, this component will be 3g cos alpha, and this component is 3g sin alpha. Now the tan of alpha is 9/40, and tan is the opposite over the adjacent. Using Pythagoras' theorem, then the hypotenuse will be the square root of 9 squared plus 40 squared, and that's the square root of 1681, and that works out as 41. So this means then that the sine of alpha will be 9/41, and the cos of alpha is 40/41. Now the equation of motion, the resultant force is the forces up the inclined plane minus the forces down the inclined plane. So here there is no force acting up the down plane, so we're just going to be subtracting the two forces down the inclined plane. So here the equation of motion MA is going to be minus mg sine alpha, that's the weight component down the inclined plane, minus, and friction is mu times R. So here this means 3a equals minus 3g sine alpha minus 3/20 of 3g cos alpha. Now we can divide everything by 3, and then a does equal minus g sine alpha minus 3g/20 times the cos of alpha. The sine of alpha though is 9/41, and the cos of alpha is 40/41. Now we can divide 40 by 20, and that does give 2. So this means a equals minus 9g/41 minus 6g/41, and this means the deceleration is going to be minus 15g/41 meters per second squared. Okay, next of all, we're going to find the distance from A to B. Now the initial velocity was 4.2. At B, the velocity is 0. The deceleration is minus 15g/41, and we're looking to find S. S is the distance from A to B. So if we use v squared is u squared plus 2s, 0 squared is 4.2 squared plus 2 times minus 15g/41 times s. 4.2 squared, using a calculator, that works out as 441/25, and then we've got minus 30g/41 times s. If we bring the minus 30g/41 s over to the left, and then to calculate s, we're going to divide 441/25 by 30g/41. And this gives an s value of 2.46 meters. So the distance from A to B is 2.46 meters. Next of all then, we want to find the speed of the particle then at A. So that's when it moves back down the inclined plane. So we need to find out what the acceleration of the particle is back down the plane. So this time, because the particle is moving down, friction is going to act up the inclined plane. And again, friction is mu times R, so that's 3/20 of R. Again, we've got the normal reaction R, and we've got the weight split up into parallel and perpendicular components. So the particle is going to accelerate down the inclined plane. So again, the resultant force is the forces down the inclined plane minus the force up the inclined plane. Mg sine alpha is the weight acting down the inclined plane, and friction then opposes that. So again, if we substitute in 3 for m, we've got 3a is 3g sine alpha minus 3/20 of 3g cos alpha. And again, dividing by 3, a just equals g times, and the sine of alpha is 9/41, and the cos of alpha is 40/41. And again, dividing the 40 by the 20 gives 2, and this means a is 9g/41 minus 6g/41, which is 3g/41. So when the particle moves from B back towards A, the initial velocity is 0. The distance from A to B is 2.46. We're only after working out the acceleration as 3g/41, and we're looking to find the speed v. So if we use v squared as u squared plus 2s, this means v squared equals 0 squared plus 2 times 3g/41 times 2.46. And if you plug that into a calculator, this works out as 441/125, or 1.88 meters per second. So this represents the speed of the particle at A. Part B then. Train A and train B are on parallel tracks and travelling in opposite directions. Train A starts from rest at minute and accelerates at 0.5 meters per second squared towards leak slip to a speed of 25 meters per second. It then continues at this constant speed. At the same instant as train A leaves minute, train B passes through leak slip, heading towards minute at a constant speed of 30 meters per second. 3 minutes after leaving leak slip, train B starts to decelerate at 0.25 meters per second and comes to rest at minute. So we want to find the distance between minute and leak slip. So if we deal with train A only, so train A starts off with a speed of 30 meters per second, and it travels at this speed for 3 minutes, which is 180 seconds, and finally decelerates to rest. The deceleration is minus 0.25 meters per second. So the distance while traveling at a constant speed is the same as the area, and that's just the area of the rectangle. So area 1 is going to be 180 by 30, which is 5,400 meters. So to find the total distance, we need to know what area 2 is also. So we need to find the distance travelled while decelerating. So for train B, the initial velocity is 30. The velocity here is 30. The final velocity is 0. A is minus 0.25, and we're looking to find out what S is. Okay, and that S is the same as area 2. So V squared is U squared plus 2S. 0 is 30 squared plus 2 times minus 0.25 times area 2, because area 2 is the same as the displacement S. And this means then 0 equals 900 minus 0.5 times area 2. And 0.5 area 2 is 900, and this means area 2 then is 1800 meters. So the total distance between the two stations is area 1 plus area 2, and this is 1500 plus 1800, which is 7,200 meters. Part 2 then, at what distance from minute do the two trains meet? So here, train A initially accelerates and then travels at a constant speed. Train B initially accelerates and it does decelerate towards the end of its motion, but we're going to assume, and this is sort of trial and error, that the two trains will meet while train B was still traveling at a constant velocity. So here we've got 3 different areas, area 1, area 2, and area 3. If we let T1 be the time that train A is accelerating, if we let T be the time that train B was moving at a constant speed, the time for train A is the same as the time for train B. So this means this remaining time is going to be T minus T1. Now to find T1, the initial velocity for train A is 0. The final velocity is 25. The acceleration is 0.5, and that time is T1. Now if we use V equals U plus AT, 25 then is 0 minus 0.5 times T1. And this means then T1 works out as 50 seconds. And this minus should be a plus. Next of all, now that we know what T1 is, so this is 50, this time then is t minus 50, and this time is t. So if we want to calculate the total distance, the total distance is going to equal total area. So 7,200 is going to be area 1 plus area 2 plus area 3. So this means 7,200. Now area 1 is a right angle triangle, so that'll be a half of 50 by 25. Area 2 is a rectangle, that's t minus 50 by 25. And area 3 is another rectangle, which is t by 30. So 7,200 is 625 plus 25t minus 1250 plus 30t. If we bring all the constants to the left, we get 7285. All the t's to the right gives 55t. And then dividing, t then is 142.27 seconds. Now this is the time though for train B. What we're actually looking for is the time for train A. Sorry, the distance travelled by train A. And this distance is area 1 plus area 2. Now, area 1 then is the right angle triangle, and area 2 is the rectangle. Now we now know that t is 142.27. So this means area 1 plus area 2 works out as 2931.75. So that's the distance train A travelled when it met with train B. And then finally, after travelling at 25 meters per second for a time, train A decelerates and comes to rest at Leixlip 36 seconds after train B stops at minute. Find the deceleration for train A. So the first thing we need to try and work out is the time taken for train B to stop at minute. And train A is going to take 30 seconds longer. So for train B, the initial velocity was 30, the final velocity is 0, A is minus 0.25, and we've defined that time. Okay, so this means 0 is 30 minus 0.25 t2, and this means t2 then is 120 seconds. That was the time for deceleration. Now, train B was moving at a constant speed for 120 seconds. So the total time for train B is 300 seconds. This means then the total time for train A is 333 seconds. So if we represent the motion for train A on a time velocity graph, so for train A, the first 50 seconds is moving at acceleration A, and it decelerates with some time t. Now the total time taken is 336. So we've got 50 plus t. If you subtract that from 336, this gives 286 minus t. That's remaining time. And then total distance is going to equal total area. So 7,200 is going to be area 1 plus area 2 plus area 3. So this means 7,200 is going to be a half of 50 by 25 plus the area 2 is a rectangle, 286 minus t by 25 plus a half of t by 25. And then 7,200 is 625 plus 7150 minus 25t plus 12.5t. If you bring the t's to the left, you get plus 12.5t, and the constants to the right, you get 575. This means t is 46 seconds. So t is the time it takes train A to decelerate to rest. If we want to find the deceleration, if we use v equals u plus at, and v is 25, u is 0, v is 0 and u is 25, and t is 46. So this means 0 equals 25 plus 8 times 46. And this means then minus 25 is 46a, or a equals minus 25 over 46 meters per second squared.